All right, number 30. Find the area under the curve of 4 minus x squared from 0 to 2. Remember, this is our limit that we're looking at. Two main things to get started, delta x and x of k. Delta x is b minus a over n. So for this one, we get 2 minus 0 over n, which is just 2 over n. X of k, for that one, we're just taking a plus k times delta x. So we have 0 plus k times 2 over n. So really, we're left with 2 over n times k. So we're substituting those things in. So 2 over n is going for delta x, and 2 over nk is going in for x of k, which really means it's going into the original function in the place of x. So let's set it up. Limit as n approaches infinity of the sum from k equals 1 to n of 2 over n, that's our delta x, our base of each rectangle, times the height of each rectangle. We're doing it in general. So we have 4 minus 2 over n k squared. So this one's a little bit nicer because we have a as 0, which makes this part a little bit simpler, a little less complicated. But now we want to go ahead and take this and do a little simplifying inside. So we have limit as n approaches infinity of the sum from k equals 1 to n. I'm going to go ahead and square that on the inside. So we have 2 over n times 4 minus 4 over n squared times k squared. Then we can distribute that 2 over n. So we have limit as n approaches infinity of the sum from k equals 1 to n of 8 over n minus 8 over n cubed times k squared. So limit as n approaches infinity of the sum of each of these. So this is where we can split it up. Sum from k equals 1 to n of 8 over n minus the sum from k equals 1 to n of this. Remember, we can bring that constant out in front, so 8 over n cubed, and then the k squared stays inside. So the sum of a constant, remember that's just going to be a constant. So the limit as n approaches infinity of 8 over n, I'm sorry, not just a constant, but we take the constant times n. So 8 over n times n minus 8 over n cubed times the sum of k squared. That's the one where we have n times n plus 1 times 2n plus 1 all over 6. So we gotta do a little simplifying. N's cancel out. This n cancels out with this one, makes it n squared. We get 4 over 3 here. And just like before, we can distribute this out, and we're going to distribute the 4 with it. Should, after a while, kind of get used to this. This comes out the same every time. Oops. 2n squared plus 3n plus 1. So we're multiplying that by 4. So we end up with 8 minus this whole thing. So we have the 4 times each one of these. We've got 8n squared plus 12n plus 4 all over 3n squared. Remember, we can split this up right here. But be careful, we're subtracting each of these. So we're taking 8 minus 8n squared over 3n squared minus 12n over 3n squared minus 4 over 3n squared. So that minus goes with all of those. We're distributing it to each one. So limit as n approaches infinity. We can do a little more simplifying. N squares cancel out. This n cancels out with one of these. So we have 8 minus 8 thirds minus, those simplify, so we get 4 over n minus 4 over 3n squared. So remember, whenever we have to take the limit as n approaches infinity and there's an n in the denominator, those are going to be 0. The limit of a constant is just a constant. So we're getting 8 minus 8 thirds. So that comes out to be 16 thirds.